Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 10 of a unit Laws of Motion. So let's begin with today's class. In today's class we are going to discuss about we are going to discuss about the centripetal force, and then next we are going to discuss about the pseudo force. So let's begin at first with the centripetal force. Let's have a look. Centripetal force. Why does it act and when does it act? So we can say that when any particle is moving on circular path, centripetal force is acting on that particle. When a particle is moving on a circular path, when each time, every time, it is having one of the force acting on it, and this force is known as the centripetal force. Okay, where does it act and how does it act? Let's have a look. Let's suppose this is the circular trajectory, this is the center of the circle, this is the radius, and your particle is there which is moving on this circular path in anticlockwise fashion. The mass of the particle is m. So the centripetal force F is equals to mv square divided by r, where m is the mass of an object, v, it is the velocity of an object, and r is the radius of circular path in which it is traveling. So centripetal force equals to F is equals to m into v square by r, where m is the mass of an object, v is the velocity of an object, and r is the radius of circular path in which it is traveling. So this is the centripetal force. Now the question arises that where does it act? That let's have a look one more time. This is the circular path, this is the center, this is the particle. So, and this is the radius. Centripetal force always acts towards the center of circle. Centripetal force always acts towards the center of the circle. That means direction of centripetal force would be look like this. It's an FC. This is FC. When particle is here, it's an FC. When particle is here, it's an FC. When particle is here, it's an FC. I hope this is clear. Yes? Is it clear? Yes? Very good. Centripetal acceleration. How do I know it? We have this Fc is equals to m into v square by r, as well as I know that force is equals to mass times of acceleration. So if I equate this to I can have this relation that AC should be is equals to v square by r. Centripetal acceleration can be equals to v square by r. So this is AC. AC is equals to v square by r. Even I can write like this, that if Fc was the mv square by r, and we have derived that V is equals to R omega. It's an m into r square omega square divided by r. This is equals to m r square r. It's an r omega square. And you can equate this with AC. So AC could be written as r into omega square. Yes, even this could be written. I hope this is clear. Now the question is, what happens? What happens if centripetal force stops acting? Yes, please think that if certain particle is there and that particle is moving on a circular path due to this force, it's a centripetal force. Now let's suppose due to some reason centripetal force stops acting, then what happens? Does particle continue to be in its circular motion, or shall it leave the trajectory? That means shall it leave the circular path? If it shall leave the circular path, where does it go? How does it go? Yes. What do you think? What do you think? What should be the correct situation? Let's have a look. This is the circular path. I should redraw it. Yes, this is the circular path. This is the radius r. Let's suppose this is the particle, and this particle is having mass m. It is moving on this circular path. That first thing is a task of centripetal force is to change the direction of an object. Yes, centripetal force is required to change the direction of an object, because if you observe this carefully, a direction at this point it is this, direction at this point it is this, direction at this point it is this, direction at this point this, direction at this point this, direction at this point this. Yes, so from tangent you can see the direction, and every instant as it is moving on a circle, a force should be there which can change the direction. Then and then your particle can continue its motion on the circular path. Now let's suppose that the particle was at point A at this situation, and the centripetal force stops acting. So at that point particle will leave the trajectory, and it will start moving on the straight line if Fc is equals to 0. So if centripetal force stops acting, then from that instant particle starts moving tangentially, or particle will start moving in the straight line motion. Yes, because there is no one who can change its direction, so it is moving on the straight line. So when fc when fc is 0, when fc is 0, particle will go on a straight path. Particle will go on a straight path, and things will be continue. Yes. Now the biggest question arises, and the biggest confusion arising is that who will apply a centripetal force, who will play a role to apply a centripetal force. So please understood this situation very conceptually, that let's suppose this is a string, and through this string we have attached one of the stone, and we are going to whirl it in a circular motion. So in this situation tension force on the string will provide required centripetal force. Yes. So in this situation, tension force on the string will provide the required centripetal force. Now let's suppose that this is the trajectory of your circular motion, something like this. Now when particle is at this situation, let's suppose denote it as an A. So if at point A string breaks, stone will starts moving in the direction shown. It will be moving in this direction then. Yes, I hope this is clear. So as soon as tension stops acting, it is moving from in the straight line manner when and when FC stops acting. I hope this is clear. Yes, because as string breaks, that means tension is zero, and in this situation tension was providing the required centripetal force to move on the circular path. I hope this is clear. Is it clear? Is it? Great. Now let's look at the second cases. Let's look at the some other cases that who will provide the centripetal force. Let's have a look. Let's suppose that you are riding a bicycle. You are riding a bicycle on a circular garden. In this situation, friction between tires and floor or flooring of a garden provides required centripetal force for cycling. Yes, so in the previous situation it was the tension who is providing the required centripetal force. In this situation it is the frictional force. It is the frictional force that provides the required centripetal force for bicycling. Let's suppose that uh, earth is rotating around the sun in circular path. if we understood this in a very strict manner, it is the elliptical path. But circle is the special case of ellipse. So for understanding purpose, we can use it as a circular path. So it is allowed to use it. Yes. So let's suppose understood that Earth is rotating around the Sun on circular path, and if it is rotating on circular path, then gravitational force, gravitational force between gravitational force between Earth and Sun provides required centripetal force. Yes. So if Earth is rotating around the Sun on a circular path, then the gravitational force between the Earth and the Sun provides the required centripetal force. So I hope now you understand that every time there are different agencies, every time there are different people who are providing the centripetal force. Yes, and this centripetal force keeps them on a circular motion. If if centripetal force stops acting, if centripetal force stops acting, that means your object is going to leave the trajectory of its circular motion, and it is going to move on the straight line from a point where it stops acting. I hope this is clear. Now, is there any confusion? Is there any confusion? Anything? No? Great. Let's work for the numericals. Question. A car of mass 500 kg is moving on circular path of radius 5 meter with a speed of 72 kilometer per hour. Find out centripetal force acting on it. Find out centripetal force acting on it. So the situation is that a circular path is there, a car is there which is moving on the circular path. This radius is given, it's an r is equals to 5, and this is moving with a speed of 72 kilometer per hour. So this needs to be converted by multiplying it by 5 by 18. This is 20 meter per second. Now what I want a centripetal force acting on it. It's an Fc, that should be is equals to m into v square divided by r. So this mass is the 500 kg. This is 500 multiplied by velocity, it's a 20. It's a 20 into 20 divided by radius. The radius is of 5. It's a 5 into 100, and this should be equals to 2 2s are 4 multiplied by 1 2 and double 2. It's a 4 into 10 to the power 4 Newton. This amount of force is acting. This amount of force is acting on a car so that it can keep moving on the circular path. So that it can keep moving on the circular path. I hope this is clear. Okay. What about the centripetal acceleration? Let's say it's an Fc by m. See, Fc, it's a 4 into 10 to the power 4 divided by mass. It is the 500. So this is equals to let's write it as a 4000 multiplied by 10 divided by 500. So we can have it's an 8 into 10, and that would be an 80 meter per second square. Yes, this is the centripetal acceleration that is acting. That is the centripetal acceleration that is acting. I hope this is clear. Is it clear? Any confusion in this? Is there anything? Anything? Is there? No? Great. Well done. Now, Now let's have one more numerical. Yes, a stone has been tied with with string as shown in the figure. As shown in the figure. Mass of the stone is 2 kg and it has been rotated on circular path with speed of 10 meter per second. If length of the string, if the length of the string is 2 meter, find tension force. Find tension force acting on it. So go through data. Go through data one more time. You might get a help. This is the stone having mass of 2 kg. A length of a string, it's a 2 meter. The length of a string, it's a 2 meter. And this is moving. This is moving with a speed of 10 meter per second. What do you need to find out? You need to find out the tension force. You need to find out the tension force acting on it. So how can you do this? How could you do this? You need to find out the tension force acting on it. You need to find out the tension force acting on it. So what could be the situation? So if I understand it correctly, that in this situation, the tension force will provide required centripetal force to move on circular path. Yes, are you clear with this? That in this situation, it is the tension force which will provide a required centripetal force to move on the circular path. I hope this is clear. Is it clear? Yes. So if I apply all the forces, then I must understand that this tension should be is equals to mv square by r. So now understand a very logical aspect, a very logical aspect of a circular motion and the centripetal force. Yes, let's understood that this is the direction where tension force is acting, and this tension force has been provided. This tension force has been provided by the mv square by r, that means the centripetal force. Or we can say the reverse sense is also true, that in this situation centripetal force is provided by the tension force. So I can apply mv square by r in this direction. Now there might be confusion that, sir, in the previous slides you were about to show it that it is acting on the center of the circle, but here you have applied it. Look at this. This is my circular trajectory and center of the circle would be this, but I have applied mv square by r in this direction. Yes, so please understand that tension, it is at the center of the circle, and this will provide a centripetal force. So one approach, that is just to do the numericals. Always apply mv square by r outside the center of a circle. While I say outside the center of the circle, I mean from center of a circle, from center of a circle to outside, from center of a circle to, we can say, to radius of circle. Yes, it is directed outward. It is directed outward. Yes, so you do not get confused by that. These are the two things that at one time you are saying it is at the center of the circle, and now you are saying that mv square by r to be acted, mv square by r to be applied on the outside the circle. So what logical thing is that here tension provides the required centripetal force. Yes, so the value of a tension should be equals to mv square by r, and it is acting towards the center of the circle. Now for your reference, what you need to do is always apply mv square by r outside the circle. Always apply from the center to the periphery mv square by r. This will make your thing much easier. Yes, so please do remember thing that always apply mv square by r outside the center of the circle. That means from the center towards the periphery you are going to apply mv square by r, and your numericals will be always correct because the rest amount of force is there in those situation will provide the required centripetal force. I hope those things are clear. Is it clear? Is it? Is it clear? Is it? Great. So now let's understood the situation that T is equals to mv square by r. Mass is the 2 kg, velocity is the 10 meter square, and the radius, it's a length, it's a 2 meter. This has gone, and in this situation tension is of 100 Newton, and when tension is of 100 Newton, that means 100 Newton force is there which acts as a tension, and this tension only provides the required centripetal force. So is it clear? Is it clear? Any confusion? Any confusion in this? Is there anything? No? Great. So now let's work for the next question. Do it quickly. Let's suppose this is, let's suppose a certain path. It's a road basically. Your car is at here. This is the one of the situation. This is the second situation. It is the position B, and this is the third situation. It is the position C. Yes. What is your question? That find out normal force acting at point A, B, and C. Yes. Assume that mass of the car is m. Yes, this is one of the favorite question, and it is there because it is a very logical question. Yes, so if you observe this a situation at A, the situation seems look like this. Yes, it is moving somewhere here in the forward direction. This is mass m. So what forces are acting? One of the force on the vertically upward direction, because this is in contact, it's a normal force. Another, it's an mg. Yes, so it is moving in the horizontal direction. No movement, no acceleration in the vertically direction. and as it is not having any vertical motion, we can write it as nen is equals to mg. This is at point A. This is at point A. Yes. Now let's observe the situation at point B. Situation is something like this. You are having a car at this position. Yes. So if you observe this, this could be represented as one of the circle. Yes. And this is the center of the circle. So now apply your force very wisely. It's a n, it's an mg, and as we have discussed that apply mv square by r outside the circle, that means mv square by r should be applying in this. So as my car is moving only in the horizontal direction, no vertical motion is there, and that's why I can write it's a n is equals to mg plus mv square by r. This is a position B. That means if you observe it with situation A, my normal is increasing. So normal is maximum. Normal is maximum at a concave section. I hope you understand this. At a concave sections. One more very important thing, that here centripetal force is providing by the n minus mg. So required centripetal force to move in this concave section, required centripetal force to move on this section is provided by n minus mg. I hope this is clear. Is it clear? Is it? So this is where difficulty may arise, that sometime you are saying that this will provide centripetal force, sometime you are saying that this will provide a centripetal force. As a student, how should I come to know that who will provide the centripetal force? And this is absolutely correct, that because as a student, how could I come to know that this is the one who is providing centripetal force for me on today? So what I need to do is always apply mv square by r outside the circle. It's from center of the circle to the periphery or to the radius, you can say it. And your task will be done, because the logically all the other force other than the mv square by r are there to provide the required centripetal force. I hope this is clear. Now let's work for the section C. Section C is look like this. Yes, here it is your car, and if you observe this is the circle. So if this is the circle, this will be the normal force. Is it visible? Is it? Yes. This is the mg, and this is the mv square by r. So what I can have, it's an n plus mv square by r should be equals to mg, and this n should be is equals to mg minus mv square by r. So at this section we can say it as a convex section. Normal force is looking like this. Now one more very interesting thing again, mv square by r is provided by mg minus of n. Yes, so this is mv square by r. So in this convex section, centripetal force, or I should say a required centripetal force, is provided by mg minus of normal force. Is it clear? Is it clear? Yes. So every time there are different agencies who will provide a centripetal force for us. How could I come to know who will provide it? Yes. So always act wisely. Apply mv square by r outside the circle. This is just to make a numerical. Yes. Again, when someone asks me that where mv square by r should be acted theoretically, I will say definitely and blindly that mv square by r is acting towards the center of the circle. But we always understand that there are certain agencies who will provide mv square by r for us. Who will provide the mv square by r? That depends on the situation, that depends on that particular sections. I hope these things are clear. So is it clear? Is it clear? Any issues with this? Anything? Anything? No? Great. So let's just wind it up this session over here. Let's just wind it up this session over here. And this is all about the centripetal force. We are going to see the numericals based on the centripetal forces, based on the circular motion, once we have done with the one more lecture of the circular motion. And then we will be able to solve so many questions based on the circular motion and the centripetal force and the certain change in parameters. Yes, so please do the one thing, revise this session and be ready once we are doing that session. Yes, thank you, have a good day, take care, bye bye.